Here you can see one logarithmic term in the right side and one logarithmic term in the left side and right side. So what we will do, so first copy that and just try to move all the terms, same kind of terms on the same side. So log 5 of 5 power 1 by x plus, you can write this 125 as 5 power 3. And if we are moving this to right side, so it will be log 6 base 5. Fine. And we already know that log m minus log n, log m base a minus log n base a equal to log of m divided by n base a. Here a value is 5, base value. Both logarithms having same base. And one input is 5 power 1 by x plus 5 cube. And another input is 6. So 1 by 2x plus 1 log base 5 of 5 power 1 by x plus 5 power 3, and it is completely divided by 6 according to this property, log of m by n. Now also you can move this 5 to left side to remove this logarithm. So now it is 5 power 1 by 2x plus 1 is equal to 5 power 1 by x plus 5 power 3 whole divided by 6. Got it? Now what I am doing is I am letting this 5 power 1 by x as I'm considering as a. To solve quickly, I'm considering 5 power 1 by x as a. Then this 5 power 1 by 2x and 5 plus 1, you can write 5 power 1 by x whole power 1 by 2 multiplied by 5 power 1. Why? Because it look like a power m plus n. A power m plus n, we know the rule, a power m into a power n. So that's why I wrote 5 power 1 by x whole power 1 by 2 multiplied by 5 power 1 and is equal to 5 power 1 by x. We already decided that was a. So a plus, keep this 5 cube as 125 divided by 6. And assuming this thing, 5 power 1 by x square, 5 power 1 by x as a, and root a, you can simply write root a or 5 into root a equal to a plus 125 by 6. Do cross multiplication or also, okay, 6 is moved that side. So 6 5s are 30 root a is equal to a plus 125. And moving this number also this side, then it will be a minus 30 root a plus 125 equal to 0. I am trying to express this one as a whole square. Is it possible? If it is not possible, in this step we will do whole square. There we are getting a large number. Okay, let's figure it out. Suppose you can write this one as root a square. Okay, you can write a as root a square, and this is a quadratic equation in terms of root a's. Replacing root a with t, root a with t again. So then equation become t square minus 30t plus 125 equal to 0. We have to solve this quadratic equation. 125 we have to split into two factors, that will give us a 30. So which numbers is possible? 25 5s, what you say? If both are negatives, then if you are adding minus 25 minus 5 will be minus 30. We are getting this minus 30. If you try to multiply minus into minus plus, 25 5s are 125. Fine. It's look good. So t square minus 25t minus 5t plus 125 is equal to 0. So take t common from the first two numbers. So it is t minus 25. Take minus 5 common. T minus 25 is equal to 0. Now again, we can have t minus 25 is multiplied by t minus 5 equal to 0. So of course we have roots. T minus 25 is equal to 0 or t minus 5 is equal to 0. Now what is t stands for? T stands for, we already know that it is root a. So root a minus 25 equal to 0. Here also replace t with root a. And again, we know that what is a? A is 5 power 1 by x. Again, we are replacing a with 5 power 1 by x. So of course it is 1 by 2x is equal to 25. Okay, so just I moved this 25 to right side. And here also 5 power 1 by 2x is equal to 5. Now this 25 you can write square and okay, here 5 as 5 power 1. Bases are equal, so the powers are equal. So 1 by 2x is equal to 2. Now reverse it. 2x is equal to 1 by 2. Just reversing. And here also bases are equal. Bases are 5, so the powers are equal. Just reverse it. If you reverse 1 also, we have 1. So x is equal to 1 by 2 as a one solution, or x is equal to 1 by 4 is another solution. So now we have to check whether out of these two or satisfies the given equation or not. Let's check 1 by 2. So look at the problem. If it is 1 by 2, I think 1 by 2 is good fit for here, right? Because we know that a power x is always positive. So no problem, both are solutions. Okay, this type of problems will be asked in multiple type of questions, multiple choice questions. Means more than one correct answer type, you will be asked these kind of problems. And next, moving to next problem. 17.4. 17.4. Let us solve 17.4. Nine power log x base 10. So 9 power log x base 10 plus, can I change this bases? Can I exchange the bases? You know the property. 9 and x, you can change their original position. So you can write 9 log x base 10. You can exchange their 9 and x places and is equal to 162. So these two quantities are looks like same. So you can write 2 times of 9 power log x base 10 is equal to 162. So 2 got cancelled in 162 2 times. So 9 power log x base 2 is equal to, this is 81. 81, you can express 81 as 9 square. And both sides, if you see, the bases are same, so the powers are same. So the power in the left side is log x base 10 is equal to power in the right side is 2. You can use Scorpion technique. So x is equal to, follow the tail, 10 power 2. 10 power 2, of course, it is 100. So therefore, 100 is the answer of this question. And next we will solve 9-5. So 9-5 is also a similar type of problem. This is also similar problem. But in the previous question, we have 9, but here it is. So see, m and x, you can exchange their places. So m power, you can write log x base 2. Plus again, m power. I am not changing anything in the second term. And is equal to 2m square. Okay. So these two quantities, m log x base 2, m log x base 2 look like same. So 2 times of, you can write m log x base 2 is equal to 2 times of m square. 2 got cancelled. And both sides, the bases are same. So the powers are same. Log x base 2 is equal to right side power 2. So use Scorpion technique. So x is equal to, you can write 2 power 2, which is 4. Answer. Next, we will solve sixth problem. So what should we do? Here you can also use Scorpion technique directly. So what is the overall input? X minus 15 is overall input. So write down that first, this one. Write down that x minus 15 and follow the tail. What is the next number? You can see 4. And next number, you can see, write it down as a power. And next number, you can see root 2. Write down as a power. Next number, you can see power 0. Fine. So from pairwise, from the top, we are calculating. Pairwise from the top. Two numbers we are solving from the top. Okay. So 4 square and root 2 power 0, it is 1. And again solve pairwise. 2 power 1, you know it is 2. And 4 square, you know it is 16. And we will send this minus 15 to right side. 16 plus 15, of course, it is 31. This is the answer. In this way, we can solve using Scorpion technique. Next, seventh problem. And here we are unable to use Scorpion technique. And before you observe that it is log base 5. And this is also log base 5. We will use this opportunity. So log base 5, and these are irrational numbers. So root 5 plus 2 whole power x minus root 5 minus 2 whole power x. Okay, and we are moving this number. And before that, I made some changes. This 3, you have to make that quotient 3 as a power of 2. Okay, so 2 power 3. And is equal to what left? Only 1 by 2. Now both values having same base, log base 5. So you can use the formula log m minus log n as log of m by n. So log of m by n means log of with base 5. So root 5 plus 2 whole power x minus root 5 minus 2 whole power x divided by 8, because 2 cube is 8 and is equal to 1 by 2. And you can send this base 5 to that right side so that logarithm will be vanished. So root 5 plus 2 whole power x minus root 5 minus 2 whole power x and whole divided by 8 is equal to, this base is moved to right side, so it will be 5 power 1 by 2. Fine. Now, this 8 is also moved to right side. Therefore, root 5 plus 2 whole power x minus root 5 minus 2 whole power x is equal to 8 times of root 5. Fine. Now we can see, if you consider, let root 5 plus 2 whole power x as a. Let us consider like that, equal to a. And try to rationalize this root 5 plus 2, rationalize it. This is all rough work. I'm trying to rationalize this root 5 plus 2. So I want to create root 5 minus 2. I want to multiply root 5 minus 2. And the whole thing will be happened under power of x. I'm just rationalizing this numerator. And you can see here, a plus b into a minus b, you can use that rule. A plus b into a minus b means, of course, it is a square minus b square. So root 5 square minus b square means 2 square divided by root 5 minus 2. And whole thing was powered by x equal to a. Now square and root got cancelled. Clearly, this is shows 5 minus 4, which is 1, and divided by root 5 minus 2 whole power x is equal to a. If you reverse this fraction, so of course we have reversing, just reverse it. Root 5 minus 2 by 1 or root 5 minus 2 is equal to, reversing means 1 by a it will be. So now we have a clarity that if you replace this thing, this entire whole power x thing, this entire value with a, of course the negative value should be 1 by a from this conclusion, and is equal to 8 into root 5. Okay. Now try to solve this quadratic expression. So it will be a square minus 1 by a equal to 8 root 5. So a square minus 8 root 5 a minus 1 is equal to 0. Of course, this is a quadratic equation. So a is equal to, you can write minus b. Minus b means minus of minus 8 root 5 plus or minus root of b square. 64 5s are how much? 5 4s are 20. 5 6 are 30, 320. So b square is 320 minus 4ac. 4 into a into c is minus 1. I'm solving this quadratic equation by 2a. 2a means 2 into 1. So of course a is equal to minus of minus plus 8 root 5 plus or minus 324. 324 is a square root of 18. 18. So you can write 18 square, of course 324, so 18 by 2. You can cancel 2 overall from the numerator terms, so that we got 4 root 5 plus or minus 9. Okay. And now you can see what is a. A is nothing but root 5 plus 2 whole power x. A is nothing but root 5 plus 2 whole power x. And is equal to 4 root 5 plus or minus 9. So root 5 is equal to 2 point, approximately it will be 2.25 something. We will check what's this value. Root 5. 2.23. 2.23, and it is multiplied by 4. It will be 8.9 something. So only plus 9 is valid, not minus 9. If you check 4 root 5 value also, approximately 8.9. So 8.9 plus or minus 9, it should not be, power x should not be negative. So only 4 root 5 plus 9 is valid, not negative 9, minus 9 not valid, and whole power x. Now take log on both sides. Take log on both sides. So log of root 5 plus 2 whole power x is equal to log of 4 root 5 plus 9. If you see, according to logarithmic rule, x into log root 5 plus 2 is equal to log of 4 root 5 plus 9. So x is equal to log of 4 root 5 plus 9 divided by log of root 5 plus 2. Of course, it is the answer. If you try to figure it out, this value, can do that also, or keep that logarithmic terms. Understood? The next.
Yes, sir.
Now try to solve this problem. Of course, I think it is already solved. No, new question only. Try to solve it. This is what a power 2x minus 3, and we will write a power 6 minus x and b power 5x divided by b power 2x. Using the property a power m by a power n, a power m minus n. So therefore a power 2x minus 3 minus 6 plus x is equal to b power 5x minus 2x. So if you try to solve this, a power 2x minus x, 2x plus x, 3x and minus 9 equal to b power, how much is it? 5x minus 2x, 3x. Now you can write this one as a power 3x by a power 9 is equal to b power 3x. Now I am moving this b and I am moving this a power 9. So a power 3x by b power 3x is equal to a power 9. You can write a by b whole power 3x is equal to a power 9. This 9 and 3 got cancelled. So a by b whole power x is equal to a power 3 times. Now take log on both sides. Take log on both sides. So log of a by b whole power x is equal to log a cube. So logarithm will make whole power as a quotient. So x log of a by b is equal to 3 log a. Now x is equal to 3 log a divided by log of a by b. That means 3 log a base a by b. This is the answer. said least possible or something, then you can use arithmetic mean is always greater than or equal to geometric mean, this rule. So here you can see two different quantities. Okay, fine. And find the least possible value of x. We have to identify a least possible value. So copy that problem. So log sin x, you can write by log cos x plus log cos x divided by log sin x. It says 2. So I just used the rule of log a base b. Log a base b, you can write log a by log b. Similarly, log b by log a. Of course, if you say it is a, it will be the reverse value of that thing. Reverse of that thing. Understood? So if you reverse this quantity, automatically you are getting this one. So if I said simply it is a, of course it will be 1 by a, right? It is very clear. Try to do LCM. So LCM is a, and this is a square plus 1 is equal to 2. Now simplify this equation. A square plus 1 is equal to 2a. A square minus 2a plus 1 is equal to 0. Of course, you can write a minus 1 whole square is equal to 0. That means a minus 1 is equal to 0 or a is equal to 1. What is a? A is nothing but log sin x or cos x, no problem. Okay, we will write sin x only. Why we change the pattern? So log sin x by cos x is equal to 1. Of course, log sin x is equal to log cos x. We already learned that if single logarithms exist on both sides, you can cancel. So sin x is equal to cos x. Sin x is equal to cos x. He is asking the least number of possible values. So that means, of course, x will be pi by 4, 45 degrees. This is the least number that satisfies this equation. Also, there are some other numbers. If you add 2 pi, automatically those all equations satisfy. Out of this least value he is asking, so 45 is the correct answer. Because of these trigonometric rules, you can add pi. Okay, and later we will study about these trigonometric equations. And the next problem, it is all completely inequalities. I will show you how to do that, 1 or 2 problems. And next problems you can try yourself. And from this class, we completed the task of logarithms. And we will get back to limits concept again. So solve for x if this thing is greater than or equal to 0. Okay. So here you have to memorize or recall the information about logarithms and inequalities. I already told you if some numbers is there, for example, x is greater than y. So numerically, I will give example as a parallel example. So for example, take 4 is greater than 3. This is theory point and this is example. So let us choose two numbers x comma y such that x is greater than y. So apply logarithm on both sides with a base a. Okay, on both sides. And it will be same inequality if a is more than 1. If a is lies between 0 and 1, then automatically the inequality will be changed to less than to greater than and greater than to less than. If base is more than 1, the same inequality will be existed. Okay, now coming to this point. Look at the first problem. First problem, root 3. And we know that root 3 value is approximately 1.732. It is more than one base, right? More than one base. So is that inequality is changing or keeping same? If you are applying logarithm or removing logarithm, so you can write 1 as 0 as log 1 base root 3. You can use same base, right? We know that log 1 is 0. So whenever you see 0, there you can use log 1 with appropriate base that you can cancel both sides. Since logarithm cancel with base root 3 and it is more than 1, so inequalities never change. Okay, so x square minus 10x plus 25 is greater than or equal to 1. Still the inequality is same. Observe this thing. Look at the next problem, point 2. That means inequality will be changed. Next 3, it is not changing. Okay, so try the remaining 2 problems. So now what we do, we will move this 1 to left side. So x square minus 10x, you know, the further calculation, you solve so many inequalities. So therefore, it is x square minus 10x plus 24 is greater than or equal to 0. And 24 can be 6 and 4, both are negatives. So x square minus 6x minus 4x plus 24 greater than or equal to 0. So take x common, x minus 6. Minus 4 common, x minus 6 greater than or equal to 0. So x minus 6 of x minus 4 greater than or equal to 0. So therefore, you know how to real line pattern. This is minus infinity and this is plus infinity. What are the root values? 4 and 6. And you know that it is plus, minus, and this is plus. So what is required? The required inequality shows greater than means positive numbers. So where it is positive from 6 to infinity, from minus infinity to 4. So therefore, if x belongs to minus infinity to 4, is it closed interval or open interval? Closed interval. Union to 6 to infinity will be the solution set of this equation. Okay. Next, try to solve the remaining 2 problems.